morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Honors Geometry class. Oh boy. All right, guys. Today we're going to be talking about Pythagorean Theorem and space figures. By space figures, no, I don't mean figures that are in space like Star Wars. Space figures, I am referring to polygons. Okay? And these space figures, or these polygons, actually not polygons, they're really prisms. That was erroneous. Polygons that are in 3D shape are called prisms. So sorry about that. It's my bad. Okay. When you have a rectangular solid, like the one right here in front of you, this is called a prism. It's basically a 3D figure. You could think of a box. That's a prism. Okay. A prism has the same size, and shape for the base and the top. What do I mean by the base and the top? Think about a box again. When you lay it down on the floor, the bottom part, that's your base. That's what it's resting on. And the top, for example, is what you open. So for us, I'm going to try to do it as best I can with color. The green is the bottom, or the base. And the red here is the top. Okay? Now, there are all sorts of types of prisms. This is called a rectangular prism because both the base and the top are both the same shape and the same size. They're both rectangles. But you can have a whole slew of different types of prisms, as I've shown you right here. Okay, I'm not going to spend forever on this page, but this is a video, so you could pause and look at what I'm talking about. This is a triangular prism, because there's a triangle on the top and the base. Yes, sir. Come again? Yes, give me 1 second. Thank you. All right, guys. So we have triangular prism. We have a square prism, which is called a cube, because all sides are squares. Here, my front or base here, that's a pentagon. So that's a pentagonal prism. This is a hexagonal prism because the bases, the top and the front, are both hexagons. This is an octagonal prism, etc., etc. Okay? Again, prisms are 3D figures that have the same shape and the same size as a top and the bottom. So both the top and the bottom of this triangular prism are triangles. Both the top and the bottom of this cube are squares. Both the top and the bottom of this pentagonal prism are pentagons. Both the top and the bottom of this hexagonal prism are hexagons, etc., etc., etc. So that is what a prism is. Please be aware of that. In order to be a prism, you have to have the same shape and the same size on the top and on the bottom. Think of a can. A can. Don't you have a circle at the top and a circle at the bottom? That's a prism as well. That's called, to be exact, a cylinder. Sir?
So what would like a pyramid look like?
A pyramid is not a prism. We're going to talk about pyramids in a second. Okay? But a prism, once again, has both a top and a bottom that are the exact same shape and the exact same size. Okay? Just like this rectangular prism here. Has a rectangle on the top and on the bottom. Now, for a prism, you have a lot of different facets to this. You have faces. You have the front, which is A, B, F, E. You have the back, which is D, C, G, H. You have the base, which is A, B, C, D. That's the bottom. You have the top, which is E, F, G, H. Then you have side 1, which is A, D, H, E, and you have side 2, which is B, C, G, F. You have a lot of components to this. So those are the faces, okay, or the sides that make up this prism. The edges. The edges are these guys. It's where the two faces meet. And let's put some stuff together. Remember when we talked about planes? Each side or each face of this prism is a different plane. And don't planes intersect at straight lines? Guys, you with me here? So all of these are edges. These are the intersection, basically, of two planes. Okay? So we have a lot of edges here. All of those are edges. AD, AE, AB, DH, DC, HE, HG, GF, GC, FE, FB, and BC. All of these are edges because it's the intersection of two planes. Everything I'm highlighting in blue here are edges. You guys with me here? Promise? Okay. And then you have, really important here, guys, diagonals. The diagonals here would be, I'm going to do this in red. Actually, I'm going to do this in black. The diagonals would be HB. It goes through this, from one vertex through the center to an opposite vertex. HB is one diagonal. AG is another diagonal. It's going through the empty space of that prism, or box, if you would say. CE. CE. It's going from here through the empty space to here. And last but not least, DF. It's going from D to the empty space to F. You've got to be able to visualize this, or you are going to have a major problem with this lesson, my brothers. So, being that this is a box, okay, prisms have a length, which you have highlighted here, a width, and a height. So again, when you're thinking about prisms, think of a box, okay? And the type of prism that you have is determined by the faces that are equal, by the top and the bottom that are both equal. A cube is also a rectangular solid, but where every single side is a square and all of the edges are congruent, okay? The D here, these would be the diagonals, because they're going through the empty space of the cube. B, this is the base diagonal. There's two different types of diagonals. You have a prism diagonal, which goes through the empty space, which is in red here. That's the prism diagonal. And then you have the base diagonal. The base diagonal is the diagonal on the actual base of the figure. This is hugely important. Like, really important, guys. Please, I'm going to repeat it. The prism diagonal is the diagonal that goes to the empty space from one corner to another. The base diagonal is the diagonal which is literally on the base. The prism diagonal goes to the empty space. The base diagonal goes to the actual base, goes to the actual side of the base. Do you understand the difference here, guys? Yes, no, maybe, kind of, sort of? Okay. And then S is the side or the edge length. And of course, if it's a cube, all of the sides are congruent. And those are the basics of a prism. Now we're going to learn about pyramids, and then we're going to learn about how to commingle the Pythagorean Theorem with pyramids and prisms. Are there any questions, and I mean it, anything, guys, on prisms before we move on? I know this can be complicated. I know it can. I want to do a good job here. Yes, no, maybe, kind of. Don't be embarrassed, for real, please. Okay? a rectangular square pyramid. A pyramid, my friends, is different than a prism. A pyramid, as you can see, rests on one base. And all of the other sides or faces are the same shape. This is a square pyramid because I have a square as the base. But it's called a pyramid because all of the faces are triangles. So every single pyramid, the faces are triangles. What determines the kind of pyramid you have is the one base that it has. Completely different than prisms. Prisms have both a top and a bottom that are equal. They're both either squares or pentagons or rectangles or triangles. A pyramid has one base that can be any polygon. And the faces of that base, of that pyramid, are all triangles. That is the difference between a pyramid and a prism. Huge difference. Again, this would be horrible drawing, but that is a prism because the top and the base are both the same shape. But if I did a pentagon, for example, again, I apologize, my drawing is going to be awfully ugly. I'm going to have triangles, pretend that that's lifted up 3D, as the faces of that one base. Big difference. You feel me, guys, even though those are ridiculously ugly drawings? Yeah? Okay. All right. A pyramid always has an apex, or what's also known as a vertex. That's this guy. That's the apex. That is the top of the pyramid. Okay? And the base, of course, is what the pyramid lies on. It's what it's standing on. It's kind of like the foundation. Think of the pyramids of Giza in Egypt. Okay? They're up, they're 3D, but they're all on a square base. Now, when we're talking about pyramids, there's quite a few things we have to memorize. Okay, first of all, S. S is the slant height. The slant height is literally on one of the faces. It is the height of one of the faces. It is on the face. That's why it's called the slant height. Okay? H. The H here is the actual height or altitude of the figure. It's going through the center of the figure. It's going through that empty space. It's going from the apex all the way to the base. And it is the actual height of the figure itself. The actual height of the figure itself. And B is the side length. And since this in particular is a square pyramid, all the sides are equal. So you got to remember these nuances, these differences between pyramids and prisms. We still have plenty of time to go over the examples. So do you have any questions at all on prisms or pyramids? Yes, sir. Thank you, my brother. Slant height. Okay. It does go from apex to base, but it's literally on the side of the face. No, this is on the side of the face. The height is here in green, my brother, and that's an altitude that goes straight up and down from the apex all the way through the empty space of the pyramid to the base itself. thank you. That's the number one confusion, by the way. So thank you very much. You just helped out a lot of people. Anyone else have any questions on this, my brothers? Okay, now's the fun part. Okay, guys. The dimensions of a rectangular solid are 3, 5, and 7. I want you to find the diagonals. All right. So here comes the fun part. Let's make this a 5. Let's make this guy here a 3. So this is a 5. Try to color code it to make your life easier. This is a 3. And this here is 7. Okay? I want to find, though, the diagonals. There are two different types of diagonals here in this prism, as we learned. There is the prism diagonal, and the base diagonal. Okay? Now, this is a rectangular solid. So that means the base here is a rectangle. So this is a 90 degree here. So the first thing I'm going to do is find the base triangle. The base triangle. The base triangle. So I want to find BD. Okay? You with me here? How do we find BD? Pythagorean Theorem. 3 squared plus 7 squared equals BD squared. 21 plus 49 is 60. Square root both sides, brothers. 4 times 15 is 60, so this is 2 square root of 15. That is my base diagonal BD. Do you see what I did there? Do you see how easy it actually is? Yes, sir, my brother. 9 plus 49 is not 60. Maybe I should learn how to multiply. Wow, epic fail. Thank you, son. There's no excuse there. I should pay attention. I apologize sincerely. How about we do it with the right math? That would be nice, Mr. Morrow. I am a fool, and I apologize. 9 plus 49 is usually 58. So again, there's absolutely no excuse there. My bad. Square root both sides. So that would be 29 and 2, so you can't. So this would be the square root of 58. Again, I'm sorry, class, and I'm sorry for everyone out there in the internet. I apologize. No excuse. Thank you, son. Now, we're going to find, let me put a different color here because it is all about, I want you to see the colors. We're going to do the prism diagonal now in purple. So the prism diagonal goes from H, according to what I have here, through the empty space to B. You feel me here? Well, I've created another right angle here. What is this height right here, though? Guys, it's 5. We already know my diagonal here. So what is my hypotenuse? 5 squared plus square root of 58 squared equals my prism diagonal HB squared. So this time I will pay attention. 5 times 5 is 25. Plus square root of 58 squared is 58. That equals HB squared. 25 and 58 is 83. Equals HB squared. Square root of both sides. HB equals square root of 83. And that, my friends, is how you find the diagonals of a prism. Please always be cognizant of which diagonal they're asking for. Sometimes they ask for the diagonals. That means they want the base. and the prism diagonal. Sometimes they just say base diagonal. Sometimes they just say prism diagonal. If they say diagonals, they're looking for both. This is huge on the SAT. We still got plenty of time. That's going to be used a lot in your homework. So do you have any questions on that before we investigate how to work with a pyramid? Yes, sir. Thank you.
But how do you know? It says 3, 5, and 7. How do you know where to put the?
Okay. The question was, you randomly chose the 3, 5, and 7. Yes, I did. It will not matter where you put the 3, 5, and 7. I promise. I promise you. No, it doesn't matter, because even if I put the 7 here and the 3 here, wouldn't this still be the hypotenuse and it'd be the same, right? Even if I put the 7 over here and the 5 over here and the 3 over here, you're still going to work out the same way. In the end, you're still going to have your diagonals there. Does that make sense, son? You sure? Promise? It's a good question. It's actually a great question. You had thought it was not a good question, but it was amazing. Okay? You with me here? And actually, yeah, it doesn't really matter. Yeah. Yeah, doesn't matter. Okay? Okay. We have some confusion as to where you put the sides. And okay, it doesn't matter, and it kind of does matter. We have to use a little bit of logic here, guys. A little bit of logic. So let me erase all of this here for a second. Now, according to this diagram here, it's pretty evident that AB is the largest. Okay? AB is going to be the largest. So that has to be my 7. And then as far as the 5 and the 3 go, according to this diagram, you can tell that AE is larger than AD, so that would be the 5, and this would be the 3. But to make your lives easier, what I will do is I will label them for you. I will tell you where the sides go, because it is a fair argument what you're saying. And if I were to switch the 7 and the 3, I get the same answer. But if I switch around the 5 and the 3 and the 5 and the 7, you will get different answers. On the SAT, they will give you where one of them is at least, and then you can plug in the other ones accordingly. So for our quizzes and tests, you have my word. I will tell you where they are, because it is a very good question. Does that help? Thank you so much for your courage, sir. God bless you. Okay, may I continue, boys? Thank you, gentlemen. I really appreciate it. Okay, for example, here, I went ahead and labeled everything you needed. Given the regular square pyramid shown with altitude PR, so PR we're going to do in red, that's my altitude. Okay. We've got PS is the slant height. We're going to do that bad boy in blue. JKMO, that's the base. Okay, it has a perimeter of 40. So if a square has a perimeter of 40, that means that each side is going to be 10. Very good. Right? Each side will be 10. You feel me here, guys? Okay. They tell me that PK, which is the edge here, not the slant height, but the edge, is 13. I want to find JK, PR, and PS. All right, boys. This is where the Pythagorean comes in. If I take PKS, don't I have a right triangle here? Right? And since this is a pyramid, these edges are congruent. Since PS is an altitude, that means the perpendicular bisector theorem is instilled. So that means that this splits into 5 and that's into 5. So what would this height of PS be? 12. That's a 5, 12, 13 triangle. Does that make sense? Are you with me here, guys? Are you sure, guys? Promise? Okay. Now, JK, we know what JK is already because the perimeter was 40. So that's 10. So now all I got to do is find PR. PR, right here. You with me? But look at what we have, guys. If we have PRS using the slant height as my hypotenuse, what would the distance of RS be, being that it's half of the side? 5. My hypotenuse is 12, so I want to find PR. So PR squared plus 5 squared equals 12 squared. So PR squared plus 25 equals 144. Subtract 25 to both sides. PR squared equals, that's, if it was 20, it'd be 120, 119, right? Square root both sides. PR is the square root of 119. Perfect timing. Does that make sense though, guys? You promise? If you need anything, I'll stay here after class. God bless you. Have a great day, and I hope you learned a lot. Thank you very much.